Let's talk about fraction division using the measurement how many groups perspective of division. We'll start with a whole number example and then relate it to a fraction example. 1 serving of cheese is 2 ounces. A block of cheese contains 8 ounces. How many servings of cheese are in the block? In this problem, we have a total of 8 ounces, and we want to figure out how many batches of 2 ounces are in the 8, or how many groups of 2 ounces are in 8 ounces. This is the division problem, 8 divided by 2. 2 ounces represents 1 serving, so we can solve this on a double number line. Our total ounces up here, and we're going to count up the servings. So we solve this problem by measuring out groups of 2 ounces to answer the question, how many groups are we measuring out? So here we go. We measure out 2 ounces. Without gaps or spaces, we keep measuring out 2 ounces until we get to our total of 8 ounces. This corresponds to 1 serving, a second serving, a third serving, and a fourth serving. So the answer is 4 ounces. Let's look at the fraction example. 1 serving of yogurt is 2/3 of a cup. A large bowl of yogurt contains 8/3 cups. How many servings of yogurt are in the large bowl? Well, again, we have our total, and we need to measure out batches of 2/3 of a cup, each 2/3 of a cup, representing 1 serving or 1 group. So how many groups of 2/3 cups are in 8/3 cups? This is the division problem, 8/3 divided by 2/3. So let's do it. We have our cups, we have our servings. We're going to measure out 2/3, and we're going to keep measuring out batches of 2/3 without gaps, spaces, or overlaps until we get to 8/3, and that's going to be our answer. So we count up. We had 0, 1, 2, counting our groups, 4 total groups. Now at this point, you should notice that these guys look very similar. The pictures are almost the same. One big difference is that here we have thirds versus whole numbers. So that takes us to a big idea. As long as you have a common denominator, so here we had the thirds, we can think of the fraction division problems like whole number division problems. We're going to roll the third into the unit because 8/3 is 8 parts, each worth 1/3 of a unit. So down here we can write this 8/3 of a cup. 2/3 of a cup is 1 serving, and that'll give me 4 servings. So we essentially have the same problem. Why? Because when we look at 8/3 divided by 2/3, we have the same thirds. That just is our label, how big our parts are, and the count is what we're dividing, the 8 and the 2. With whole number division, I can always check my answer. 8 divided by 2 is some number. I should be able to get the number of servings times 2 ounces in 1 serving is 8. Does that work? 8 divided by 2 is 4. 4 times 2 is 8. We're going to do the same thing with fraction division. 8/3 divided by 2/3 can be checked by plugging our answer into the corresponding multiplication equation. So we'll check this. 8/3 divided by 2/3 equals 4. So it should be true that 4 times 2/3, well, I'm going to make this 4 over 1. Do my fraction multiplication, multiply the numerators and denominators, 8/3, and I'm good. So with fraction multiplication, you multiply the numerators and denominators. It turns out that we did the same thing here with division. This was actually 8 divided by 2 over 3 divided by 3. 4 over 1 is 4. That leads us to an algorithm that some people haven't studied before. So we can have the algorithm that we divide the numerators and divide the denominators in fraction division. We're going to look at another problem that looks like the one above because it has a common denominator. Mitchell can walk 3/5 of a mile while listening to one podcast. How many podcasts of the same length will he be able to listen to if he walks 3 miles? Well, if I think about how to solve this, 3/5 of a mile is one podcast, another 3/5 of a mile is another podcast, and so on. So I'm going to be measuring out 3/5 of a mile until I get to 3 miles. But 3 miles would be easier to compare to 3/5 if I had the common denominator. So how many groups of 3/5 are in 3 miles becomes the problem 3 divided by 3/5. We're going to solve this as a common denominator problem. We should get five as our answer. Let's solve it with a visual method. So our total was 3 miles, so we'll do miles. And what are we counting out or measuring out 3/5 of a mile, which are worth 1 podcast? Each tick is going to be 1/5 of a mile. 3/5 will be one group. So this will be 1 podcast. I can keep measuring out groups of 3/5 until I get to 15/5. That's my total, so I just count up here. And indeed, my answer was 5. I can check this. 3 divided by 3/5 equals 5 means that 5 times 3/5 had better give me 3. I can just cancel, and indeed I get 3. I don't actually have to have a common denominator. I can just divide numerators and divide denominators. This algorithm is particularly efficient when we have a common denominator or when we have a situation like this next problem where the denominators, 20, the dividend's denominator, is a multiple of the divisor's denominator. And similarly, in the numerator, 9 is a multiple of 3. This becomes the problem. 9 divided by 3, 20 divided by 5 is 3/4. Well, let's check it. If that's true, then 3/4 times 3/5 had better give us 9/20. 3 times 3, 4 times 5, yep, it gives us 9/20. We can also check this by turning it into a common denominator problem. So let's do that. 9 divided by 20 divided by 3/5. We want to know how many groups of 3/5 are in 9/20. But let's give this a common denominator so we can easily measure it out. To get our common denominator, we're going to have 20 in the denominator. I get 9 divided by 12, which is 9/12. Let's think about what we've got here. We have our total is 9/20. That's the first number. So that's our 9/20. That's where our answer is going to be. And our groups are 12/20. How many 12/20 are in 9/20? Not even one 12/20 is in 9/20. So I can circle my group. I'm going to overshoot here. This is one group. How many groups of 12/20 are in 9/20? Not even one group. Well, what fraction of a group? Let's count up. How many spaces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This will be 9/12 of the group. So you'll notice that I have been providing number lines that have matching tick marks. The reason for this is because we don't always get whole number answers. For example, in this case, we had a fraction of 1, so we wanted to be able to mark 1 and then count up how did we divide 1 up into 12 parts, and I only needed 9 of those 12 parts. This algorithm works nicely for common denominators. It works nicely for problems such as this. However, if you come down to a problem like this one, this algorithm can get really messy, and so we might choose to use a different one to have a more efficient solution process.